Okay. Hello, everyone. Welcome to our industrial and research conference. So the first team which is going to present is Mr. Naveen and Ram Prasad on the topic encoding temporal and spatial cues for road incident detection in planet setting. So, team Naveen and Ram Prasad, we can start.
Morning, sir.
Good morning.
Sir, our project name is Encoding Temporal and Spatial Cues for Road Incident Detection in Vanet Settings. Myself, R. Naveen, and my teammate name is Ram Prasad. Objective of our project is to develop an RF-based IoT, RF and IoT-based protocol for real-time incident detection and response. It's basically used for accident occurring in hill stations. To prevent that accidents, we are setting an RF transceiver and receiver in cars so that if any accident happens, the emergency response it's directly sent to nearby vehicles and emergency stations.
Continue, please.
Yes, sir. Abstract of our project. This project proposes an RF and IoT-based emergency communication protocol for Vanet to enhance response time. In IoT indications, enable real-time monitoring. In our project, we can monitor the real-time data and we can obtain the data using a IoT cloud-based. We can also track where the accident happens and our nearby emergency stations and hospitals can easily go through.
Okay.
So, Ram Prasad will explain the existing systems in our projects.
Go to previous slide once.
Literature review now. So,
Okay. You also have to explain a bit from the literature as well.
yes, sir.
Okay.
So in 2003, this same like this accident detection system is developed, sir, but it varies from our project.
Okay. How?
They don't.
Guys...
Yes, they really don't. They don't. One second. Sir.
Or did you guys updated anything from this idea?
Yes, sir. We can track the live location of the distressed vehicle, sir.
Okay.
Thanks.
Okay, you can explain this at last. Ram Prasad, you can continue.
Good morning, sir. Sir, XSC system has been developed to detect the incident in vehicle in ad network system by encoding temporal and spatial cues. This XSC system typically utilize components such as power supply, Arduino, and LCD with I2C interface and a vibration sensor. These GSM and GPS based on vehicles accident detection and alerting system using vibration sensor. This project employs two Arduino and a vibration sensor to detect the accident and a GPS module to determine the vehicle location and GSS module to send the alert notification. Post.
Did you guys build any prototype?
Yes, sir.
Okay, you have it with you in your hands right now?
Right now, we don't have it.
Okay, done. You can share a video of it whenever you find time.
Yes, sir. Yes, sir.
Or if you already recorded video, you can also show it to us.
Sir, in the end of the video, we'll show.
Done.
In the
Okay. Continue.
Post. Proposed method. So proposed method. So proposed method utilize RF transmitter and IoT factors. Why can use the RF transmitter? It continuously broadcasting the location and status of the vehicles. That's only use the RF transmitter. And there are two sensors I will including this proposed system. One sensor of gyroscope and vibration sensor. Why can use the vibration sensor to any accident detected? Any accident can be detected to the vibration sensor to alert the message and go to the emergency response. That's all. That's why I can use the vibration sensor. And one GPS also using this. Why can use the GPS? The real time monitoring the incident. Real time incident monitoring. And IoT model also used to enable the cloud-based data management. Cloud-based data management, sir. And on receiver side, alert trigger. There are two sides, receiver and transmitter. Receiver side, alert trigger and emergency response throughout the RF receiver and buffer. These method can be multi-hop communication network, ensuring the faster emergency response, reducing delay and providing the routes.
Sir, in block diagram, in transceiver side, we are using a Arduino Uno microcontroller and giving a power supply. There's an input, vibration sensor, gyroscopy sensor, and GPS.
This block diagram appeared to represent by Arduino-based vehicle monitoring and control system. Control system using the sensor, wireless communication, and IoT connectivity. First, you can use the power supply. Provide the power supply to Arduino and other component. And the sensor input to Arduino. Vibrations. There are two sensors: vibration sensor and gyroscope sensor. Vibration sensor why can use to detect the vibration possibility to identify accident. Why can use the gyroscope measuring the angular velocity used to identify the accident. And one model GPS model can use track the location of the vehicles. And Arduino process input. Why can Arduino process input on the central microscoping this process sensor data? Output from Arduino. LED used. Indicated from the system status. Bottom section of transmitting of IoT integration. Arduino processing unit. Another Arduino that process using in receiver side, sir. And next one buffer like to alert system to warning signal, and on LCD display showing the real-time data to alert, and on power supply unit provide to power to the Arduino system. That's all, sir. Any doubt?
Okay.
The working principle of our project. So there's a vibration sensor detects sudden shock or collision, and gyroscopy sensor measures the changes in velocity in a vehicle. The sensor attached to the Arduino, and it sends the vibration or any collision, and sends the data to the microcontroller. And there's an location GPS module which used to track the exact location of the distressed vehicle. And we are using a ESP8266 IoT module. This is a Vanet based communication. In this, the data is transferred from vehicle to vehicle. Conclusion of our project, sir. In the conclusion, the proposed system, RF-based emergency communication system in a Vanet setting, offer a significant improvement in reducing response time during a road incident. We can,
Okay.
by using our project, we can reduce the response time, and we can detect the accident on time, and we can rescue the persons
Okay.
by utilizing
So
data transformation of multi-hop communication. The distress signals are promptly relayed to the nearest emergency units. Using multi-hop communication, the distress signal is transmitted to the nearest emergency stations and hospitals, and that's it.
okay, got it. So project idea is good. So now please explain about at what stage your prototype is in, or what's the stage of this research.
So
Then
we are,
explain some of the literature reviews you have done, because
okay.
this is the idea which has been tried by a lot of people for a lot of so many. I think past few years, a lot of people are trying on this. So explain some of the literature review part and also the prototyping part, and how big is it going to be a device, which are the vehicles which are compatible, how it is connected to the, like, who will receive the signals.
Yes, sir.
For example, if a lorry or vehicle is carrying that,
Yes, sir.
suddenly there's some accident happens.
So when a vehicle is registering in RTO itself, we will fit the device in it. With Vanet, sir. Every vehicle that registers in RTO will be given this device. And we when an accident is appearing, before it senses the data, and it's sends the data to nearby vehicles around the accident zone, sir. Any vehicle that near the accident zone, the data will be transferred using IoT, sir.
Transfer to the nearby police station or hospital.
Nearby emergency stations and nearby vehicles.
Okay.
Using a buzzer, it indicates that an accident happened nearby, so that then the nearby vehicle can contact. Will just when vehicle is registering, they'll give their friends or families numbers and their address, so that when accident happens, the data the data will share to the nearby vehicles or emergency stations, so that they can call their.
Understood. So basically, when the device is being allocated for a specific number or vehicle, the numbers associated, maybe friends, family,
Yes, sir.
or some possibly hospitals, the information should go. Okay.
Yes, sir.
Maybe you can do some detailed research. Have you done any? Have you done the prototyping or trial and error?
Sir, we have done the prototype, sir, but I'm not having that video. I can show in the.
Have you tested?
Yes, sir.
Okay.
I've tested.
Tested in any vehicle?
No, sir. We just made the prototype and it's working properly.
Got it. So next upgradation will be, maybe keep it in your bike or possibly even a cycle. Maybe just try whether when it may be hitting or some incident, it has to pass the information to the friends or family.
Yes, sir.
If that is successful, then it will be good. Then yeah, maybe at the end of the presentation, like the entire presentation, you can show the video if you have.
Yes, sir.
You have the
Yes,
video
sir.
with you?
Yes, sir. Yes, sir.
Is it in your lab now?
No, sir. Not in my lab, sir.
Okay, got it. Yeah, because I maybe stop the recording after you guys present. If you guys present it now, it will be part of the single recording. That's it.
But I'm not having in my laptop.
No problem. Say okay, pa. Maybe end of the or
Session,
when
I'll
all the presentation is over,
Yes, sir.
please share it. I will add it
Yes, sir.
in this video.
Okay.
Okay. So audience, viewers, if you have any questions, you can put it up. We have Naveen and Ram Prasad. They have just presented their research topic and they have done a prototype as well. You have any questions? You can ask. You can also share your feedbacks as well. Naveen, Ram Prasad, try to engage the audience.
Yes, sir.
Okay, if you can ask any if they have any doubt or any questions related to your topic.
Or else, if you have any ideas, we can put in our project. You can.
Yeah, your inputs will be. We have a question. Yes.
So basically, you mentioned previously that you are using some cloud-based platform, right?
Yes, sir.
What kind of platform is that? Can you mention in
ThinkSpeak. We're using ThinkSpeak.
ThinkSpeak? Okay,
Yeah, it
okay.
was mentioned there.
Yes, sir.
Okay, what if the zone have no connectivity like that? Accident zones.
So not
Can't.
If the accident zone does not have any internet connections, means what will happen?
That's why we are using RF transmitters, sir.
Okay.
The
Sure.
data is collected and using RF, we can send. We don't need any internet.
Okay,
vibration
done.
also.
Thank you, sir.
Any other questions? Okay, done. So thank you so much, team.
Thank you.
She is stopping the recording now.
Yes.
Start now, please.
Yes. Sir, in the right side, you can see the transmitter side where the vibration is detected and it sends the data to the receiver side. You can see the relative's name and their mobile number. And you can also see their register numbers, their vehicle number.
Yes, nice.
And then it will there is a buzzer in receiver side. When the accident is detected using this buzzer, you can know that the accident is happened nearby, and you can, with the given data, you can proceed calling their relatives or their friends, or else you can transfer the data to the emergency stations or hospitals. That's it, sir.
Down below. Okay.
So that's it.
Okay, done. So
Okay.
now we have to try some trial and error by keeping it in some vehicles.
Yes, sir.
And see whether the data is transmitted. How to now it is like prototype. You need to convert
Yes,
that
sir.
into a product
Product.
or a
Yes.
box. You have to make it like a box. You have to fit it inside the vehicle receiver with a ground station. You need to do all those stuff.
Yes, sir.
Okay, thank you.
Thank you, sir.